Hello, good morning to all participants. We will wait for 5 or 10 minutes because others are also still joining. So we'll start in 5 minutes. Nikhil sir, good morning. Kumar Jarat sir, ITI Malegaon. Sushti ma'am, can you start or wait for some 5 minutes more?
Please start.
Sorry?
Start.
Okay. We'll wait for 2 minutes, then we'll start. So hello, good morning to all the participants, and thank you for giving your precious time to us. I am audible. Someone please. Hello, I am audible. Okay. So today we are going to conduct webinar on automation studio software. So With me, my colleague Chaitanya Gaikwad is also here, who is attending this Automation Studio webinar. And with us, our CMD, Mr. Sunil Chori, is also in the meeting. So we'll proceed now. So Simosoft is based on Simosoft technology is based on Pune, and we are in domains like hydraulics, pneumatics, mechatronics. We are also in artificial intelligence. We are in robotics. We are in electrical domain also. And our CMD, Mr. Sunil Chore, having 23 years of experience in education and in corporate sector also. So we have a industry grade softwares which we are providing to colleges. In that we have a automation studio software which we are conducting today, Mastercam, Flexim, Visual Component, and many more different softwares which work in different domains. And along with those software, we also provide hardwares also, and like electro hydraulic trainer kit, electro pneumatic trainer kit, robotics kit, uh, whole smart factory with IoT and digital twin. And by using this combination of software and hardware, we provide complete lab setup. And we have already established a number of labs. So moving so this is our official website. You must visit and check all the information. Now, just a minute. I will share my screen. Screen visible? So this is our Simsoft Technology official website. On that, you got all clarity. What software we are using, we are providing. What hardware we are providing. How many labs and where we are established. What product we are selling. What services we are giving. So all information you got here. So I would like to show you some videos which we already have established the centers. I will show you 2 3 videos of like we have established. Just a minute. So now I show you the video of our Vidya Pratishthan Baramati Center of Excellence. Video visible? Just a minute. No? Hmm? Correct me. Just a minute. Huh? So this is the video of our already established Center of Excellence in
Robotics जवळपास 4,000 स्क्वेअर फुटावर ग्रामीण भागाचं ग्रामीण वाढत असेल पहिल्या स्मार्ट फॅक्टरीला नियमित करायचा निर्णय आपण घेतला आणि त्याचं काम आज आपण या ठिकाणी सुरू झालेलं आहे. अभियांत्रिकी अभ्यासक्रमाच्या विषयीचं बाहेरील विद्यार्थी असो कंपनी कर्मचारी असो उद्योजक असो यांच्या गरजा आहेत त्या गरजा पाहून तसं प्रशिक्षणचे प्रोसेस तज्ञांच्या मार्फत या ठिकाणी घेता येतील आणि यासाठी केंद्र सरकारच्या स्किल इंडिया उपक्रमाअंतर्गत सर्टिफिकेशनची सुद्धा त्याला मान्यता मिळते आणि प्रशिक्षणासाठी येणाऱ्या मुलांच्या दृष्टीनं ही अत्यंत आनंदाची गोष्ट आहे.
As we celebrate this momentous occasion, we are not just inaugurating a center, we are embracing innovation, empowering communities, and bridging the gap between rural and urban technological landscapes. This center symbolizes the convergence of tradition and cutting-edge technology, demonstrating that progress is not confined to urban spaces. As we stand here in India's first rural center of excellence in digital manufacturing and robotic automation, I am reminded of the transformative power of education. Education is not merely the acquisition of knowledge, it is a catalyst for innovation, a gateway to progress, and a key driver of social change. The students of this esteemed institution are not just learners, they are the architects of our future, equipped with skills and knowledge needed to navigate the challenges and opportunities of the digital age.
सकाळचे अध्यक्ष प्रतापराव पवार प्रतिनिधी या सगळ्या सहकार्यांना मी अंतकरणापासून धन्यवाद देतो. मी त्यांना विश्वास देतो की तुमची साथ तुमचं सहाय्य याचा उपयोग एक सक्षम आणि कर्तृत्वाला दूरदृष्टी असलेली नवी पिढी तयार करण्याचं आव्हानाची पूर्तता तुमच्या मदतीनं या ठिकाणचे आमचे अध्यापक त्यांचे सगळे सहकारी प्रयत्न सुधारण्याकरता करून उत्तम करतील हाच विश्वास या ठिकाणी आपण देतो.
Infinix GT30
So,
5G Plus.
This is the video of our Vidya Pratishthan Center of Excellence. Now I would like to show you the our NTTC Nagaland video. Just a minute. Okay. 1 minute. So in Nagaland, we have already established one Center of Excellence, NTTC. You must go through this video also.
We Simusa Technologies are proud to announce one more Center of Excellence at Nagaland Tool Room and Training Center, Dimapur. So crossing borders of Maharashtra, now we have established one more state-of-art center of excellence.
Welcome, the Honorable Chief Minister of Nagaland.
Nothing like here, and then we could get Nagaland's first state-of-art center of excellence in Industry 4.0. Look like great people.
So this is all about our Nagaland Center of Excellence. Now, in KPP Satara, Karmir Bharava Patil Satara, in that Red Shikshan Samstha we have, Engineering College we have recently established a Center of Excellence. So this is the small video of this KBP Center of Excellence. Please go through it. So those are some of our Center of Excellence videos. We and we have a number of ITs also where we have already established CNC manufacturing labs. So those are we are doing under the PPP fund or CSR fund. So today we are going to conduct automation studio software webinar, and through this webinar, definitely you got good knowledge about the software. The software contain 20 plus modules like hydraulics, pneumatics, proportional hydraulic, proportional pneumatic, OPC client, digital twin, and many more. So with me, my colleague Chaitanya Gaikwad will hand over this session. We will conduct the session further. Thank you. I would like to invite Chaitanya.
So, hello everyone. Hello. Yes. So, hello everyone. Myself Chaitanya Gaikwad, and thank you Satta for such a great start. So, firstly, I'll introduce myself. Myself Chaitanya Gaikwad, and I have completed my BTech in electrical engineering, and I am as an application engineer in Simisoft Technologies, Pune. So I look after the electrical, robotics, and the automation part. So today we are going to see the one of the most powerful and very integrated and very vast and very beautiful software. It's named as Automation Studio. So I will start with this software right now. Okay. Hello everyone. So is my screen visible? Okay, so as of you are you can see this is the basic interface of our automation studio software, where we have all the different tabs and the different functions in our upper side. Then on the left hand side we have all the different libraries and all. And so first I will start with the why we need the simulation software. Okay, so just now my colleague Saddam has shown you what the great the most the great and beautiful labs which we have set up yet, and you can see there was many simulation softwares along with the hardware kits. Okay, now for any institute or any training centers and alliances where where we train the students on different technologies like fluid power, hydraulics, pneumatics, then in control system like PLC, PIDs, then for robotics, process control, electrical or electrotechnical domain. Okay, so these all are having the hardware kits, but we cannot give all the students these kits in free hand or without any uh, safe at a safe environment. Okay, so but this software allow us that safety, because here in this software we can freely connect and make all the and simulate all the circuits, all the fluid power circuits and all, and we can experiment with them, because this software allows us to do mistakes and learn from them. Because and this reduces the 60 to 70% accident and the safety, and also increases the understanding of students before going hands on to the hardware field. Okay, so as we can see, and this software as one of our as here we can see, I have written that I hear and I forget, I see and I remember, and I do and I understand. So when you are just listening and watching the videos or the only the animation of any particular technology, you are not getting it much hands on. Okay, but when you are particularly you are selecting the components, connecting them, giving the power, and then simulating it and see how the circuit is behaving and how the technology is working, how is there is the flow okay, or the power flow, how it does really works. So from this we really understand it. So that's why we say I do and I understand. Okay, so very and now I will directly go to the come on to the automation studio software. So this software is used for designing and simulating the automation systems, electrical systems, hydraulics, pneumatics, then instrumentation and process control, robotics, electrical, digital electronics, electric vehicles, and many more. So in today's agenda, we are going to see the how we can create the EV circuits, small EV circuits, and how there are the different components, and also that from that we can easily show students how there is an energy flow to from right from battery to the wheels of any vehicle, then how the internal circuits or the relay logic of an car or any electric vehicle does work. And then we are going to see the instrumentation and process library. Then we are going to see the robotics library in the automation studio software. Okay, so this software integrates and connects many modules. So you can see, and it is very easy to connect. We have to just connect the dots and select the components, connect the dots, and play. And we can see all the magic or the software does, and we can easily understand everything. And it is just not like any other software or any other just a presentation that just the line is going from one end to second end and there is the connection. No. This software gives us the precise parameters, all the properties of a particular, just for example we are taking any motor, any fuse, any hydraulic valve or anything. So now, so firstly, I'll introduce you to the libraries of Automation Studio software we have. So firstly, we will start with the fluid power. We have the hydraulic uh, system. So here you can see we have all the components and the required for any hydraulic system, like pumps and intensifier, hydraulics actuated valves, reservoirs, direction control valves, flow valves, and all. Okay, so and then we have the process valve. The same way we are having the library of a proportional hydraulic system, the same way we have the library and all the components for a pneumatics and proportional pneumatic system. Then we can control those systems with manually, electrically, or with automation, or with PLC and other things. Then we have the drive and transmission, where we can connect all the mechanical components, like right from engine to the mechanical jump, gearbox, clutches, then the wheels, measuring instruments like tachometer, mechanical multi gauge, torque indicator, power gauge, steering wheels, connected to the shaft, connected to the PIDs. Then we have the other components like fans and all. In environment and control, we have the components like control devices, joysticks, and all, for the precise or the proportional control. Then from here,
Chaitanya,
yes sir.
after 5 to 10 minutes, please keep asking whether they are understanding what you are showing, so that it can be a, interactive session instead of only, one-sided.
Okay, sure sir.
Involve them so that we'll come to know whether they are getting it or not.
Yes. So I request all the participants, you can directly, as I'm showing the screen, so I'm not many times I'm not visible able to see the comments, see in the comment section. So please, you can directly switch on your mic and ask any question or any doubt or any inquire any something related to the software or the screen. Okay. So and I will also frequently ask if there is anything skipped, or you want anything extra, or you want to see any particular term or the parameters in the technical way also. So here, as we are going down, we can see we have the ladder diagrams. Okay, so we can, as I have mentioned the term PLC. So basically, for many softwares, it is softwares are used for particular PLC only. But this software is that where we can see, we can use all the many different types. Like here we have, I have opened the PLC, illustrated PLC. Okay, so here you can see the Allen Bradley PLC. So I have the Allen Bradley PLC right now. Then I have the Eaton PLC. Then I have Mitsubishi and Siemens as well. Now here we can see it's just the front view of a particular PLC of Siemens, where S7-1200. But we can see all the input output ports, power ports, then the relay outputs, its communication protocols, and ID. And when I'm going to switch on this, the particular LEDs will also glow on ups and all. So this is the actual replica of your all hardware into the virtual environment, so that you can have the feel that you are using the real components, because I cannot afford to give all these things like electrical, PLCs, robots, and all to all hardware to us, all of my students at a time. Okay, if we have the batch of 30 students, 40 students, but we can do that. We can give them the 30 users of this automation studio software, and then one hardware kit, so that 60 to 70% work will be done on the software. They will get to understand the technology, they will get understand the connections, they will understand the process flow, power flow, and then they can confidently work on the actual hardware. Because the main issue is either if there is a lack of knowledge, or if they don't know what is the connection type, just there is a term like syncing and sourcing. Okay, if they didn't understand this and directly worked on the hardware, they could may damage the system, or may any accident may happen. Okay, so these things are being reduced in this. So we are entirely reducing the all hardware cost with the help of this one software, because this is giving me the PLC also, electrical also, robotics also, process instrumentation also, hydraulics also, and pneumatics also. And nothing is left anything in this, and really with the software part. Okay, so we have the all the hardware and actual field which we are going giving on the hardware, we are doing it on simulation. Okay, so I was here with the electrotechnical. Then here we can see the in electrotechnical I have all the control and power components, right? We can take it from the DC motors, AC motors, stepper motors, to many things. And one more important is the HMI and control panels. So I can just I'm not just connecting the components and the uh, just a second, the components and the just simulating it, we are comparing with the actual hardware. So I have all the uh, components which are moving actually just when, and we have to start the simulation. As I'm getting started, I can easily just switch on, switch off, and connect it with all the things. So now today we will start with the building a small electric vehicle circuit. So today I am going to show you first one simple relay logic for controlling the headlight and the indicators of our car or our vehicle, any vehicle. Okay, so what we need for that and how the components we are going to see. Let's see. Okay, so for that, for particular circuit or for particular domain, I have the different projects or the standards. Okay, so the white screen in between you are able to see, this is for the particular domain. Just like in documents, we can see the standard diagram is for our hydraulics and pneumatics, electrotechnical is for all our electrical diagram, electrical components and electrical domain. One line diagram for the all our the one line diagram circuits and all. Then we have the panel layout, we have the ladder diagram to for PLC programming, we have 3D diagrams, then the robotic diagrams for robot environment, we have the SFC aspects, then block diagrams, multi-technology, instrumentation, and process control. Okay, so for different technology, we have the different project diagrams. So in this project, we are going to see the electrical part or the EV part now. So I'm getting started with the. So firstly, what we needed is the power source, right? So I am taking one 24-volt battery, and now see, this is our battery source. Now let me show you. When I'm double clicking on it, we can see all the parameters and the properties of this particular component. So we will start with the battery, just not the just it's adjusting its voltage and current, but the capacitance, its resistance, and then the battery capacity, initial charge, initial resistance, and other things also. So firstly, as in our any vehicle, we have the 12-volt battery. So I will just convert it to 12-volt. So everything, each and every component is customizable. So as per our need, as per our convenience, or as per our project requirement, we can change the parameters easily. Now I have connected this battery. Now I'll connect. Now I need, firstly, I'll do it for the indicator and headlight relays. Okay, so I will go to the control sub sub library where I have the other difference also. The major thing is, firstly, I'll go to the switches, and here I have the multi-position switch, right? So from here, I will take multi-position. and I will just rotate its side very easily. You can see now, and from here I will just give this. And one more thing, that I will take one more switch or a toggle switch. In switches I can get each and every type of switch we have, like push button, NO type, NC type, LED connected push buttons. Then I have the key lock push buttons, then toggle switches, and all other things also. So I will take the NO type, the toggle switch with make contact, means manual return. Okay, so I will name this one. Now I will get the all the here I will take the relay coils. So here we have all the different types of relays now, just like 120 volt AC, 230 volt AC, 12 volt DC, 24 volt DC, 48 volt DC. So from this, I will take 12 volt DC as my system is working on 12 volt DC source. So from here, I will get connected. So this I will name as L left. Okay. So this one will be for my left indicator. The same one, same I will take another one. I need to right now. Right. Then I will take one more for my head. And this software is completely Windows friendly, so we can use all the shortcut keys which we are using for our Windows applications too. So I'm giving name. And one more interesting feature this software gives us is for animation. So I'm also going to show you how we can give the animation. So now I will just directly connect. Now I will just move this. It will go. So you can see this is symmetry. I can either connect this all and give them to the return path. So all my positive and negative ends are connected perfectly. Here we can see all the A1, A2 points, connecting points, and the terminals very clearly. Now what I have done till yet is I have just selected the components and connected all the dots. It is just simple as we are making a rangoli by connecting all the dots. It is that simple, and I have nothing. But now here is one important thing, just that I have also have to make sure there is a proper protection. So I will take one single fuse and I will name it as well. So this is my blown fuse. As you can see, there is name coming like we can see it is 32 ampere. From settings we can easily change it from 32 to whatever the security parameters we need, like 6 amperes, 5 amperes, and also here we have connected everything. Now what will happen when we are I am closing this switch or this multi position switch, the particular relay will get energized. Okay, from this particular relay we are going to switch on the different LED or the different lamps. So for that I will go to the signaling devices. In these signaling devices, I have the different types of lamps, pilot lights, rotating lights, and audios, horns, bells, buzzers. Okay, so from here I will take one lamp. Directly we have the option of 12-volt DC lamp, so I will just take this one. One for and this one. Okay, now I will. There is one thing that I can just the other end, like neutral end, I can directly connect it to the negative part, or I can just do a simple thing. From here I will check if I have ground. For now we can connect this also. Okay, so here now I have to give the actuator. So now I need the relay contacts. So here in this I have the relay make contact, break contact, 3-pole contacts, and all other systems too. From here I will take one make contact, and now I have to connect with this with any particular relay. So for the first LED I will give name as left indicator. Okay, so I will just type a search here left and click over here, and we can see the hyperlink is being created. And also we can see as it has turned to the blue, and automatically this name has come over here, means the hyperlink has been created. And this when this relay will get on, this relay contact will get closed, and our particular lamp will glow. Same thing we will do for the headlight, and for our this is our headlight, right side indicator. So this is my right indicator, and I can easily see I will get short and take supply from my battery. Uh, so there is one more thing that we also need to give protection to this our headlights too. So I will just copy and paste them. And if there is any wrong connection, I can easily use the shortcut just like Control Z or anything, and we can undo at the complex circuits at all. So this is like little bit just complicated. If anyone is getting like that, just ask any question if you have. And I have connected all the fuse for protection of our lamps. And from here in simulation tab, I can start the simulation. I will just change it. So here you can see when I'm closing the if I'm switching my multi-position switch to left side, my left relay is on. In middle, the thing is on, and from right side, the right relay is on. And here, the headlight is on. So this way we can connect them. Now I will show you the animation part. For that particular, in Home tab, I have an option to the to insert any image or any other things, just like we insert into our PPTs and all. So from here, I will take one headlight which I have already downloaded. I will just stretch it. See, this is stretch, and then now I will take one more. Take the we will just minimize this one and then copy, paste, and rotate it side. So this is to show the left and right. Okay. Now here we can easily see we also have the CAD drawings features. So I will just give the animation now. In the here we have the option for give animation. Okay, so here these 9 types of different animation we can give, like translation, free rotation, blinking, visibility, resizing, continuous rotation, and all. So I will give this visibility translation, where initially the symbol will be invisible and then it will get visible. And the same way I will search here about for the headlight. Okay, headlight is connected, and now for our left indicator we will see the blinking. Here visibility, we can also give the time, how much time it can be visible and how much it will be invisible. And it is connected. The same way it will be, we will give the blinking sign for our right indicator. So this is connected, and now we can see now everything is closed. Whenever we have observed that when we switch on the headlights, then only the headlight symbol is visible. So you can see when my headlight relay is getting on, at that time my headlight symbol is there, and when I'm switching to my left indicator, it is getting blinked. The same way it is for the right indicator. So such visibility, rotation, or other animations also we can design for the proper learning and all. Okay, so this was the basic one, basic circuit, where we can understand how the power is coming to the relays, and then after that it is going to the lamps or other things. Now I will show you the one more circuit. not this one. Now I can show you how from a battery we are connecting any inverter or the power converter, and then easily we are we can give the power to our wheel, and how the mechanical drive components are being connected. So I will just make it fast now. Here I will take one battery. Okay, so this will be my 12 volt, and then from my power library I will take one energy converter which will convert my this DC to AC. From transformation tab, I can easily just rotate my battery or the component size. In motors, we have all the different types of DC motors, single motors, three-phase motors, synchronous motors, and all. So I will take currently one motor. So we just want to see the angular speed of motor. That's why I will just keep this one only visible and connect all the dots. Now, what we will do, from our environment and control, I will take one control device. Give a name is as V, and we will take one more thing. From here, we will take one pedal. So to show that how when we press the pedal, how the supply is going to the motor and its speed will get increased. Here we can in data we will just see, as we have connected a three-phase motor, so I will just connect I will set the value to 400 volts. Then in my PD I will set this value to 50, so that 0 to 50 hertz as we are having the frequency. And then in our uh, inverter in frequency I will just select the PD. For frequency, and for line voltage we'll select the B. Now when I'm getting started with the supply, as we can see, when so here we can see we are all having the different. We'll just check the my converter. We have connected everything. think okay, got it. So now we can see that here the from this side the voltage is getting changed, frequency is getting changed. PID is being getting activated and all. Screen stop. So here you can see when I'm increasing the pedal output, at the same time the voltage and frequency is getting changed, and from the our energy converter till the supply is going to the motor where we have connected the variable load. We can see the RPM also, and we have connected the tachometers, gearbox, and then a wheel to our system to show the simple transmission. So now we will start with the instrumentation and process, where we will see now the instrumentation library components, and then I will show you a simple hydraulic system in the instrumentation process diagram. Okay. So in instrumentation and process diagram, we have the two parts. Like the first one is the contact with liquid, which will be for the our hydraulic system, and for the contact with gas is for our which is referring to our pneumatic system. Okay, where the steam powers and all. And in this we have added the turbines and heat exchangers, then instrumentation devices. Okay, so first we will see the generic part, and then we will move on to the illustrated components, which is more interesting and very easy to understand also. Now here I have taken one pump, one centrifugal pump, connected one motor. We have taken a reservoir from where the fluid is coming, going to the centrifugal pump where motor is on and it is supplying the power. Now here I have connected one check valve, then one normally open two-way valve, and here we have the internal tab back pressure regulator. So when it will get on, when if there is a particular in hydraulic system, it needs an particular pressure so that it will get on. Okay, so for to measure this all, we will see I have the different pressure transmitters. So I will connect one pressure transmitter over here. Then I have in this I will take one turbine in which in the we can say flow transmitters we have horrific type transmitter, fighter type transmitters, then a turbine type. So I will take this one turbine type, and we will also see one pressure meter, differential pressure transmitter, so that I will connect over here. Okay, now we have connected everything, and we will also check whether what is the temperature inside the all the connections and all. So this is our temperature. We can also check the differential pressure gauges, thermometers. Now we will start with the flow, where you can see now the flow from how the flow is going through the arrows, like it is coming from this reservoir to this centrifugal pump, then from there to this check valve, where we can also see in live demonstration we can see how the check valve's cracking pressure it is getting deflected. See, we can clearly see the deflection also. At the same time, here also we have one NO valve. When I will click on it, it will just close this part. And when I'm just closing this one, the flow, liquid flow is stop. Okay. Now see, when I'm reducing the cracking pressure of this valve, then the flow is going from over here. So we can also adjust the cracking pressures. Now this was for this libraries a small circuit where we have the two path 1 and path 2. Then the same way it is for our contact with gas, we have the measuring instruments like transmitters, flow, pressure. Then they have the different one like two-way, three-way check valves. Then in self-actuated valves also. In this, we also have one more thing that is the heat exchanger. So sometimes it is like pneumatic or hydraulic heat exchangers and other things which are actually used in industrial PNIDs, then process and instrumentation and mechanical departments. So this clears all the process flow required components, which types of transmitters, gauges, and the components, power components are being used, types of valves for the hydraulics, pneumatics, and steam powers, and also the replica. We can replicate the SCADA features for monitoring or the animation. Now, I will show you one more circuit where we have the illustrated library. Now, firstly, I will show you the PID components of illustrated library where we have a liquid tank of two types. Then we have the transmitters, we have the pressure transmitters, then flow transmitters, temperature and gas transmitters, level transmitters, which one of them I have used over here. In that we have two, a radar sensor type also and a capacitance rod type also. Then we have the different controllers like programmable controller or the PID controllers for chilling or heating purpose, where we can give the inputs for the particular we can set this for particular switching, like if I have set the for 110 degree centigrade it will get switched off, and after if the minimum temperature is 130 or any 90 degree centigrade, it will turn on. Such types of connection also we can do over here. So from this I have created one simple closed loop, a system where you can see I have one tank connected to one centrifugal pump with skid, where my electric motor is the actuator to this pump. Then here I have NC motorized valve, adjustable signal range. Okay, so I can adjust the all the pressure by the use of this pedal. So I have used this pedal to control this motorized valve. Then here we have one fail closed diaphragm. Okay, this is also a two-way valve, which is which will be on when there is a particular pressure only. So that's why I have also connected one pneumatic supply to this valve. And by this arrows, you can easily see how the supply is going. Here we have the another tank where all the water or the fluid will get transmitted, and here we can see the liquid level capacitance sensor, which will indicate us the water level of this. Okay, so I will just start with the simulation. We can see the motor is started running, and when our pedal is getting on, see I have also set at this temperature, where you can easily see when I'm wearing it, this valve is getting up. Okay, so I have to connect it in the switch way, and it should get open to the path. And now I am increasing the NC motorized valve connection, and you can see the flow, it is coming from the first reservoir, then to the pump, then to our valves, and it is going to the second tank, where the water level is getting increased slowly, and we can also see the animation how the water level is increasing in different products. Okay, is there anyone having any doubts, or I want to ask something related to the instrumentation and delete? No, we can continue to the robotics part. Okay, so I think there is no doubt. So we will start with the robotics part now. So I will just close this, or here only I can show you how we can add the robotics. So I will switch my standard diagram to the robotic diagram, so that I can get the robot simulation environment. So this is our the plane where we are going to import all the robotic components. So in here, in last, we have the robotics, all the robots. So firstly, as in this new robotics library, they have introduced us to a 6-axis articulated robot and 4-axis Cara robot. Okay, so I will just drag and drop both of them. See, so this is our 6-axis robot, and this is our one of the Cara robot. 4-axis car robot. So in this robotics lab, students can easily learn the robot kinematics, robot teaching, robot different axes, its workspace, and different how its application is being used in industry or in automation line, conveyor setups for the different applications like welding or pick and place or any other. Along with this robots, we have so different tools like a cylindrical tool or the suction tool. I have just connect this over here, and you can see the automatically my suction tool is connected at this end effector. Okay. Now we have the different types of loads like a spherical load or any prismatic load. We have those things. Along this, we have the sensors, we have the conveyor belts, where we can also define the conveyor length, width, its parameters. We can create any connecting conveyor or actual setup of any conveyor setup where the robot conveyor will be on, and robot will we can place the different application as per the sensor inputs. Okay. So we can attach the sensors to our conveyor. See, as any object will come from this end and pass the sensors, it will get signal, give signal to the robot, then robot will pick and place. But for that purpose, I have to place my robot as per its uh, work in workspace. So or its reach. Like for example, for a Scala robot, its pitch is of as per our need, like 400 mm, 700 mm, for 6 axis, for 1000 mm, whatever as per its length and all. Okay. Now I will show you how we can show you the control panel and other things. Okay. Firstly, you can see now here I will take one load. Okay, I have taken this, and in the robotics tab, I have one. When I'm selecting the robot, yeah, I have an option of control panel. So as I have said, all the robot kinematics. So here we can see the dragger modes, how the mouse selection mode, its speed, then the all the robot movements in its jog mode also, and it is in its axis mode, and the other pitch roll and yaw mode also. So here we can see the J1 to J6. These are the 6 different joints of this motor. So we can easily move them and see how the particular joints are getting moved. Individual joints I can easily move and check. So this will help for to learn how to use the teach pendant of any particular robot easily. Then we have some fixed positions to set it as its home position sample. Then in XYZ also we can see each and every joint is getting moved or to teach it. And we can see how all the X, Y, and Z object is getting moved. And here also, if I have this option, I can easily by my mouse tip, I can control the robot directions. See, now these were the X, Y, and Z. And when I'm changing my mode, here you can see these are the pitch, roll, and the yaw movements. And again, I can take my robot to the its home position. From here, I can select the any pickup point for my robot where I have to pick if there is any particular section. And here we have the direct surface or any point where I have to move this one. Okay. So why I'm showing you this? Because these are the basic robot parameters or the kinematics to check and all. Now I will show you the complete line where how we are using the conveyors, robots, sensors and the objects and make a complete automation line. Okay, here we have added all the components, the fencings and all. Here you can see we have connected a conveyor belt where at the each and every endpoint we have one sensor. So when this box will come at this sensor, the robot will pick and place on this conveyor. This is the exact replica how in the industries also the robots are being used. Industrial robot or the robotic arms are used for this system. Let's see, and the robot is coming. And at a time, two robots we have used over here. Now we will see and another example also, which is also very interesting, where we can see the robot is doing the path as per path. We have connected one welding or any point control where it will check its all the joints or the path of that particular chassis. So here we have one car chassis and the two robots. So as per its coordinates are getting reached, the robot is getting connected. So this is also very interesting part that we can take the feel of a complete automation line or industrial example where the robots are being used for pick and place, pick and place assembly or for the buildings and all other examples. We have the different conveyor setups. I can, if I have to modify this even, I can. I can attach this and uh, give the particular objects through this conveyor for mounting, like from screwing, gauging, or any other things. So this was all from my side for the EV part, then the instrumentation and the robotics. And also now we are also coming with the series of the software to explain the different modules. As you can see, it takes as the software is very vast and having this such much more modules. So it is not possible to cover everything properly in a single session. So we will take the sessions series like of hydraulics, pneumatics, and for other different modules too. And we are also, if all the faculties as there we have, if you also want a proper 2 days, 3 days, particular workshop for your students or the faculty development programs or your institutes, you can mail us or the contact us and also give the feedback form so that we will contact you, and we charge a very minimum amount for that, as like 15,000, 20,000 for the for particular workshops. Along with the automation studio software, we have the CNC simulations, robot simulations, master camps and other things also. I will lastly, I just want to say that this software is such powerful that you don't need to buy the 10 or 20 hardware kits for your students. You can just have one single hardware kit and 20 or 30 user of this software. Then all the you can teach all the 30 users at a time hands-on practical experience with they will where they can connect the theory to the industrial level. Yes, ma'am. We can also, as of we are building the center of excellence, where we are integrating the simulation with the hardware, because just like earlier also you have seen all our videos there where you have seen the PLC trainer kits, hydraulics trainer kit, pneumatic trainer kit, robotics trainer kit for 4 axis, 6 axis. You have the electrical trainer kit, Schneider electric trainer kit. So all this you will get in one pack. Yes, yes. If you, it is for the ENTC, electrical, mechanical, instrumentation, mechatronics. Ashish sir, we will, you please give your comments in. I have noted your doubt and we will get back to you. Also, please fill the feedback form so that we can earlier. Yes, yes, you can arrange the for the students also. You can arrange for 1 day, 2 day workshop, 3 day workshop for on particular module also, or a mixed module also. Any other questions? Thank you, Ashish sir. Thank you, Rupali ma'am. Webinars are our webinars are chargeable, uh, like 15,000 or 20,000 per webinars. It's being there, but you, uh, yes, we are sharing our email ID. And I'm requesting all the participants. There will be we will send you the feedback form link. Please fill that form. Please inform us how was the session. If you want any new in that, if you want to conduct any workshop, or you want to talk regarding the softwares and the hardware part too for the center of excellence and other things. Thank you so much. Any doubt? If you have sent the contact mail ID in the chat box also. Okay. Thank you all of you for giving your valuable time for our this session. I hope this will be very interesting and you have gained a very now in future also we will you will we are arranging the sessions on different modules and different simulation softwares too. Okay. So we will end the meeting in 2 minutes now. If you have any doubts or anything, you can ask or just switch on your mics and ask me.
Hello, Supreme ma'am. Sure, you can. Please contact with us in group. There is our contact number. Then we will discuss on that. Yes. All participants, please fill this feedback form. And thank you for giving your valuable time to us. And definitely through this webinar, you get idea what is a software and how it we can implement in our education. So thank you, and we'll end this session here. Thank you once again.